Today is Monday, March 16, 2020. It is official that the coronavirus is start human clinical trial today. So we're going to discuss on this coronavirus vaccine. Before we go into details on this vaccine, let's have a look at this pandemics of the coronavirus. As of today, the total case around the world is 173,285, and total deaths is 6,668. And maybe it's easier for you to understand this the total case and total deaths in terms of the graph. And here the left side is total cases, and in the right side is total deaths. You can see in both cases, and the trend still up. It looks like have an exponential increase. And because in European countries, in America, this is just the beginning, and many other countries also can be said besides China. So these cases are going to have a huge increase in the near future. And we don't know where it's the plateau, but time will tell. And let's look at individual country. And the coronavirus is affecting 159 countries and territory. And of course the virus starts from China. And China really have a good control on the situation. Right now, the new cases, as of yesterday, only have 36 new cases and have only 14 deaths. So, China really did very, very good job because they actually locked down the country for more than 1 month. So, the people are suffering in terms of freedom, but it is worthwhile to lock down the country, and maybe this is the best way for our country to do the same. And right now, the epicenter is in European countries and Italy, and the total cases are more than 24,000. And also yesterday, they actually more than 2,000 cases in single day, and not big trouble for European countries is Spain, and the cases start to pick up. Almost all same cases for other European countries like Germany and France, UK, Norway, Netherlands, Sweden, Belgium, Austria, Denmark. Almost all the European countries have started to show this effect. And of course, that in the Middle East, alone still have big trouble. So, single days is more than 1,000 cases, and that is more than 100 in single day. And the U.S., we're going to see huge number here because in the very beginning, and the United States CDC have policies test as few people as possible. In late January, and they actually test only 2 kinds of people. One, the first people need to suffer from this disease, have flu-like symptoms. And in fact, flu-like symptoms, first you need to come from China. Second, you need to have history or contact people who suffer from this disease. So, in more than 1 month, it just test about 100 or about 300 people. So, they miss a lot of positive cases. And last Friday, the President Trump announced national emergency. So right now, the United States is mobilizing this resource and to first of all to detect this virus. So this collaboration between the government, academic, and also the private company. So they have a huge resource. And now almost can test almost any cases, and you they have the capacity. And I expect this number going to be huge increase in this week. And this, of course, good thing to do, because first you need to identify the source of the virus. Because after you know you have virus, then you can isolate people who have this virus. That's the only way for us to control this virus. Yeah, it looks like the pandemic is in the full speed, and the best way to control this pandemic is the vaccine. But right now, so we have no vaccine. As I mentioned that today I'm going to talk about the vaccine under development. So this vaccine is under development. Is almost all big or small vaccine companies involved on the vaccine development. So a lot of strategy, and they are going to have a lot of products. And before we're going to look at the vaccine, let's understand how we're going to make this vaccine. We need to understand the life cycle of the virus, and we only need focus on first step of this virus vaccine. And this is coronavirus, and this is like a corona. And on outside of this virus is one spike protein. We call it S protein. And this virus get into the cell first by binding to human cell receptor. So, and this binding is very, very strong, and it's much stronger than usual binding. That's the main reason that this virus have high contagious rate. So, after this virus binding to this human cell receptor, and the virus then get into the cell, start its new life, and then produce new virus. So far, all the vaccine we are under development is try to generate antibodies against this spike protein. Because if you have antibody against this spike protein, the antibody will bind into this spike. After binding, then this virus, the spike of the virus, have no capacity to bind into the human receptor. Thus, they cannot infect human cells. That is the way to prevent this virus from getting into the human cells. So they cannot, in this case then, the virus will be died outside of cells. So, as mentioned, that all the vaccine is under development, uses this technology to generate antibody against this spike protein, the S protein. So the messenger RNA is what is quickest one, because right now the sequence technology is very, very well established. And so the sequence of the virus genome is known. So you can synthesize this messenger RNA and then deliver this messenger RNA into the body. And then the body can generate S protein. So the DNA is the same. You have the sequence of the S protein and put it in the format of DNA. Then when you inject this S protein sequence into the human, and the DNA can initiate expression of the S protein. The inactivated virus, basically you grow huge number of virus, then you purify the virus, and then you inactivate the virus, then you inject this virus into the human body, because on the virus this S protein. So, and the recombinant DNA is also used the sequence of the S protein. which can be expressed using the vector. And when this S spike protein sequence is expressed, and the protein can be produced. And the virus-like protein, actually, you first express this S protein and use technology which resemble this protein's virus-like format. So this S protein will be expressed on this virus-like particle, and then you inject this virus-like particle, the S protein, and will be delivered into this human body. So in all this technology, and they use all this technology to express this S protein, and then S protein is expressed in human body, because the S protein, the human protein, recognized as a foreign protein. The human immune system we're going to process this S protein and generate antibody against this S protein. And that's this vaccine. And as mentioned, all this approach, when you generate antibody to the S protein, spike protein, and this antibody will going to bind into this S protein. So all this S protein will be binded, will be coated by the antibody. So if this S protein, spike protein is binding by this antibody, so then he lost the capacity to bind to the human cellular receptor. And in this case, the virus cannot get into the cells, thus it will die outside of the cell. That's the principle, and to generate of this antibody as a vaccine approach. And so for you to generate vaccine, and you need to carry out clinical trial, and you have, for any vaccine or any drug, you need 3 phases of clinical trial. And you need phase 1 clinical trial. Usually you know about 50 people, and we know that any product you need to be passed, used in the human, need to be, first they need to safe, and second you need to be have effective. So the phase 1 clinical trial, the most important thing is make sure that this vaccines do no harm to humans. There's no side effect, or otherwise, if this side effect is so strong, so then they cannot be carried forward. So after pass this, of course, in the phase 1, and also you can look at some efficacy by look at how the immune response it looks like. So usually you're going to measure how many antibodies produced. And based on phase 1 data, then you carry out phase 2 clinical trials. So in phase 2, you continue to evaluate the safety of the vaccine. Meanwhile, you put some focus on see how effective this vaccine. In this case, you just how effective generate antibody against this virus. And after you have phase 2 clinical trial, and then go to phase 3 clinical trial. That's phase 3. Then it's large scale. You maybe involve thousands of participants. So there's large scale evaluation, safety and effectiveness of the vaccine. So that's why it takes a long time to develop a vaccine. For example, even in the phase 1 phase, only have about 50 people. You need to have 2 doses. You give day 1, today's day 1, you get 1 dose, and then you start to evaluate how is immune response. And then you, after 1 month, you start day 30 dose. And after you give this vaccine, you start to evaluate how good after this booster of the vaccine. So even in this case, we have even this process of clinical trial and it takes about at least 2 months for the phase 1. So that's why it takes time to develop a vaccine, even in this emergency situation. And that's our discussion on this coronavirus vaccine. And if you have any question about this, please feel free to leave a message. I'm going to give you comments. And if you like my video, please subscribe to my channel so you will get notice on my new video every time I have a new video like this. And thank you, and I wish to see you in my next video. Bye.